yeah, let us first discuss the first question, which is you are given a subarray. Array doesn't contain any non-negative integer. So none of the integers are negative. So we can say this array has all non-negative integers. Yeah, let us go ahead with the solution. So let's say, let me once write the code and I will do one diagram end to end so that everyone gets the idea. Now, I will do a small diagram for everyone to understand and then we'll discuss if someone has not understood. Now, the efficient way to solve this. So guys, we are done with the very first question. So yeah, let us first discuss the first question, which is you are given a subarray, or we can say you're given an array. You have to find a subarray with given sum. So what I mean by this. So let's say, and one more thing is like this array doesn't contain any non-negative integer. So none of the integers are negative. So we can say this array has all non-negative integers. All the integers are considered to be positive only in this array. Okay. So let's say this array has 1, 4, 20, 3, 10, 5. Okay. This is our array. It contains 6 elements and the sum is, let's say sum can be, let's make it 33. Okay. Now you have to tell me, can there be a subarray whose sum is equal to 33? And if there is a subarray, what can be those arrays, those elements? So we can see here, as we have discussed in our previous classes, that subarray is a part of that array which are considered to be contiguous among them. They can start at any point and end at any point. So we can see 23 and 10 is the subarray whose sum is equal to 33. Okay. So basically in this question, what we have to return, we have to return either true or false. So for this, it will be true. If let's say there is given an array where there is no subarray which is equal to the given sum. So it can be anything. Let's say if the sum is, let's say for this example, if the sum is 17, in that case, you cannot find any subarray whose sum is equal to this given 17 sum. Correct. So in that case, the output will be false. So this is the question. Any of you having any doubt in the question? Question is clear, guys. I hope with everyone. So yeah, let us go ahead with the solution. So let's first discuss about the naive approach. How are we thinking to solve it? So let us take one more example. Let us say we have 3, we have 2, we have 0, we have 4, we have 7. Now, what can we do out of it? Is that we have to find we will find all the possible subarrays starting for these elements, and we'll see whether any of their sum is equal to given sum or not. So let's say when we are talking about these 3, so what can make out of these 3? Multiple things, but let's start 3, 3, 2, 3, 2, 0, 3, 2, 0, 4, and 3, 2, 0, 4, 7. This all elements can you make out of this 3? Correct. Similarly, we'll try various combinations. Now let's say, okay, let me first write the sum as well. Like for this array, we want to find the sum as 6. In that case, if you see whether we start with 3, neither this sum is equal to 6, neither this, neither this, neither this, neither this. But if you start with 2, and then in another iteration you have 2 plus 0, something again 2 plus 0 plus 4, and at this point you got the number which is 6. This is going to be our approach. For every index, we are going to do multiple iterations. We are going to find all the possible combinations which can be found for that number, and we'll just see whether it is equal to sum or not, because we are just about to return true and false. If it is, then it's fine, otherwise no. We'll discuss on your approach once. Let me explain this. So let me once write the code and I will do one diagram end to end so that everyone gets the idea, and then we'll try to optimize this. So let us write. So sub array, let's make it sub int array. Given an array and a sum. Okay. So let's say what we want to do is we want to iterate on we want to check for each and every element. So we start from I equal to 0, we'll go to I less than array dot and then we'll do I plus this. Okay. Now let's maintain a variable. Let's maintain a dummy variable, we can say, which will just have a value of 0, and it needs to give us the sum of every time we are adding some elements to it. So now we are running a nested loop because we want to find all the subarrays starting from that array. Okay. So we are doing here int j equal to I, j less than array dot then. Okay. And then j plus plus. Since every one of you know the subarray, so I think it will be easy to understand. We'll just do current equal to current plus array of j. And we'll just check if our current is equal to whatever the given sum is. If it is, then we return a true. Now this thing will keep on happening for each and every, like we'll keep on doing this for each and every element till we get the sum. Now let's say we have completed the entire iteration and everything is done, and still we are not able to get. In that case, we'll just return a false. Okay. Now I will do a small diagram for everyone to understand, and then we'll discuss if someone has not understood. So it is 3, 2, 0, 4, 7. and the value of our sum is equal to 6. Okay, this was the question. Now what we have done here is that we are moving from I equal to 0 to array.length. Okay, so the value of I is 0. Okay, initially what happens, our current is also 0. So for I equal to 0, our current initially is also 0. Now what happens, the value of this j is initially 0, j equal to I, so j will also be 0. What will happen with current? Current equal to current plus array of j. Array of j is 0. So this will be added. So our current now becomes 3. Okay. This is done here. Now what happens? Our j value will keep on increasing. J equal to I, j plus plus. So j will now become 1. What happens to our current? Our current will also keep on increasing because current equal to current plus array of j. So current will now be 3 plus 2, 5. Similarly, j value will become 2. Current will become 5 plus 0. We can write 5 plus 0, which is equal to 5. Similarly, j value will become 3, which will be now at this index. Our current will again become 5 plus 4, which is equal to 9. Similarly, the value of j will become 4, and our current value will become 9 plus 7, which will be equal to 16. Now, if you see, guys, every time what is happening, whenever we are reaching a new current value, we are checking it with the sum of whether it is equal to the sum or not. Since it was not equal, so we have done all the iterations. We never stopped. We come now out of this loop. Now, next time what happens, the value of our I, now this was the condition when the value of I was 0. Now the value of I becomes 1. Okay. In that case, now what happens? Again, our current again has now become 0. So it was starting again from I equal to 1. Again initialize the value of our current as 0. The current is now again back to 0. Now when the value of j is again equal to I, so j is now 1. When j is 1, current equal to current plus array of j. So this index, if you see. So current now becomes 2 for j equal to 1. Again, it checks current is equal to sum or not. We see current is not equal to sum. Okay. So in that case, nothing will happen. Keep on doing the iterations. Now the value of j will become 2. The value of current will be 2 plus 0. Current plus array of j, this index. So it will be 2 plus 0, which will be 2 only. Now the value of j will become 3. What you see, it will be current will be equal to this index plus array of 3, which is 4. So our current now becomes 2 plus 4, which becomes equal to 6. Okay. Now what happens here is that this condition will work now. So here we'll return the true. So we got our answer and the output for this is true. So this is a naive approach, how to solve this question. Or you can say a brute force approach, where we are finding all the possible combinations and we are seeing is any of their combination sum is equal to the given sum or not. If it is, we return true. Otherwise, we return. Now, the efficient way to solve this question, which is solved using the pattern of sliding window. So what we do here is by this approach is that let's say this is a given array and our sum is 70. Now, by window, what we mean that we have to consider a few elements at once and then we either keep on adding the element to the window and removing some element from the window. Now, we don't know what will be the size of our window. So how we'll find the size? Let me explain. So let's say what initially we'll do is that we'll keep on adding the elements first till it is less than the sum. Once it increases more than sum, then we'll see whether to remove some element from the window or not. So let's say we are at this 4 and let's say we have one current. Okay. Now we have first window of size 4. Now we see like this 4 is the for sure less than 17. We keep on adding. We add 8 to this. Now our current window size becomes 12. Still it is less than the sum. So we'll keep on adding. Now after adding 12 to this, it becomes 24. So by window, what we mean is this window. With this window cannot be a subarray. Correct. Because the sum is already greater than 17. So we need to remove some elements from the window. So how we'll remove? We remove the starting element. We'll remove this 4. Once we remove this 4, what will happen? Our window size now becomes 20. Still we see our window is greater than the sum. We'll again keep on removing. We'll remove again 8. Our window size will now become 12. Since our window size has become 12, we can go ahead again adding that element. So now we'll add 5 to this. Once we add 5, again we'll have the condition check. We'll see our sum is equal to this element. And this is the efficient way. We will see once we find this, we return a true or a false. If we get this, return a true. Otherwise, anyway, we have the default false returning at the end. So again, I will go through the approach. It is a sliding window approach. We start with the very first element. We keep on adding the elements. Till that point, we see the sum of whatever we have currently added is greater than our sum or not. So we added initially 4, then we added 8, it became 12. Again, we added 12, it became 24. Once we reach 24, what happened? We'll see that now we cannot add more elements to this. Why we cannot add more elements to this? Because it is already greater than sum. Since we have mentioned that it is non-negative integers, correct? So you cannot add any more element to make it equal to sum. We have, that is the agenda of our question, correct? So we need to remove some elements. So first we remove 4, it become 20. Then we removed 8, it become 12. Now once we are at 12, again we are at a position where we can add some elements to make it equal to sum. So then we add the next element, and fortunately we got a number whose sum becomes equal to the given number or not. Okay. So this is how we return true out of it. Guys, you understood the approach. We'll do one diagram again for this. So let us write the code for this. And very interesting thing is how you guys guess the time complexity. So we'll discuss on that as well. So this is subarray. Again, similar to above, we take an array, we take a sum. Okay. Now what we do is we see, and we need to take some elements, correct? So let's say a counter for the very first, whether to increase which elements remove, since we need to remove the elements from the very starting. So we have mentioned an S has to be 0, and again a current to be a 0, just to maintain the sum. Again, we are starting one loop. This loop will start from I equal to 0, I less than array dot length I plus plus. We will see current equal to current plus array of I. This is what we want to do. After this, we will have a while loop here. This while loop will keep on checking if our current, or we can say something like this, like this sum, and if a current at any point has become greater than our sum or not. If it has become, now you know what we need to do. We need to remove the elements from the very starting. So we need to do current equal to current minus array of s because we are maintaining s from the top. So once we have removed one element, what we do need to do, we need to do s plus plus, so that we remove the next element, and we will keep on doing this. Yeah. So this while loop will close, and then inside this for loop only, we'll see if current is equal to sum. At any point, we return true. Otherwise, by default, we want to return a false. Okay. So yes, we'll do one full iteration just to make you guys very clear on the approach. What was our question? Our question was we had, our example was code 8, 12, and 5. This is what we have now, and the sum given is 17. So how this code goes? Initially, value of s is 0 and current is 0, and the value of I is 0. So let's say when the value of s is 0 and the value of I is 0, what happened that time? Current value will keep on increasing. So initially at the very first go, what will happen? Current equal to current plus array of I. Array of I is 4. So current now becomes 4. Now when value of I becomes 1, current value will become 4 plus array of I, which becomes 12. Now when the value of I becomes 2, current every time is going inside this loop only. While loop, it is every time checking. Every time sum is less than current, every time 4 is less than current, 12 is less than current. So this while loop is not executing. Neither the if is correct. So it keeps on iterating inside the same loop. Now when the value of I is 2, we see that the value of our current is now 12 plus 12, 24. Now here comes. Now when it is 24, what we see? This while loop will execute now. That this sum is less than current. Sorry. Yes, sum is less than current because 17 is then 24. So it go inside now this loop. Now what happens in this case is once it go inside this loop, the value of I will remain to be 2 only, correct? Because this was the point where we reached 24 and there only it executed. So value of I will remain to be 2, but the current would be current minus array of s. Array of s is 0. So 24 minus 4, it will be 20. And after coming out this loop, at this point, s has now become s plus plus. S has now become 1. Okay. It will keep on, now it will keep on moving inside this loop. Again, this 20 is less than, we can say again this 20 is greater than our sum. This loop will again execute. So what happens now is that again we remove current equal to current minus array of s. So remove 20 minus 8. Again, it becomes 12 and the value of s has now become 2. For these, all of them, I is still 2. If you see. Now what happens now? Now at this 12, again the while loop execute. Again we see sum is less than, whether this sum is smaller than current. No, in this case it is not. It come out of this loop. Now for this 12, it will check. If current equal to sum, no, it is not again. So again it goes. Now this time, now our I will change. I has now become 3. Now the value of I has become 3. Current equal to current plus array of I. Current is not 12. 12 plus 5, which will be 17. Current is 12 plus 5, which is 17. At this 17, it sees that 17, again this loop will not execute because sum is 17, but it is not, both are equal, not less. So it will not execute. It will come to this point. This will execute. So we return true out of it. So this was the dry run. This is a very popular interview questions. Actually, a lot of questions are being based on this sliding window approach, and it is used a lot for optimization. This is the code and the dry run. So guys, this is one of the most important, whatever we have discussed till this date, sliding window. And always whenever there's a question on subarray or something, you can always try to think that can we optimize through sliding window or not. So guys, we are done with the very first question.